Hello everyone. In this video, I'm going to talk about numbering systems. අපි සිංහලෙන් සංඛ්‍යා පද්ධති කියලා කියන්නේ. This is a very important segment in computer science. Actually, this will be used in many other areas in this particular field of study. Something like networking, memory calculations, indexing, and etc. You might see some of these in my upcoming video series. So let's go into the video. The numbering systems in computer science is somewhat derived from the numbering system concept in mathematics. So in this video, I'm not going to go in detail. So this will be a brief introduction about what is numbering system and a high level usage in computer science. So a number system is nothing but the way of the numbers or the digits are getting arranged. So in computer science, mainly we see four different categories. One is the decimal numbers. Second one is binary numbers, octal numbers, and hexadecimal numbers. So let's go in a bit more detail about these numbering systems. Decimal numbers, or in Sinhalese we call as Dashamaya Sankhya. This is the default numbering mechanism that we use in our day-to-day works. This is in this system, we basically represent one single digit in the basis of 10. If you take a number, let's say 258, and if you take this one particular digit, you can include 0 to 9 in there. So that's how the decimal numbers are getting arranged. So we can include any digit between 0 to 9 to represent a decimal number. If you take this particular example, 258, the rightmost corner we represent in 10 to the power of 0 basis, and the next level is 10 to the power of 1. The next will be 10 to the power of 2, and likewise it goes on when the number increases. So here I have included the calculation is being done for the decimal numbers. So if you take this particular example, here you can see the rightmost one, it's 10 to the power 0s. 10 to the power 0 in the sense it's gives the value of 1. So here you can see there are 8 digits in the section of 10 to the power of 0. So in that case, we have to multiply 1 by 8. So you will get a number 8. So the next level will be the 10 to the power of 1. That means it's equal to 10. So there are 5, number 5 is available in this particular section. So once you multiply, you will get the value 50. In the third section, which means the 10 to the power of 2, there's number 2. In that case, you need to multiply 10 to the power of 2 into 2. So which means 100 into 2, 200. When once you add all these values, you will get the final output. This is how the decimal numbers are getting represented. So basically in decimal, one digit will include either 0, 1, 2, 3, or a bit likewise between 0 to 9 values. Next, let's move to the next numbering system, which is the binary numbers. Binary numbers are mostly used for electronic signalings in computing, mostly electronic signaling and communication. We mostly use this binary numbering systems. So here we use this to provide commands to electronic equipments through zeros and ones. Zero means off, where very low or no electric voltage will be sent, and one means it's on, where a working electric voltage is sent. So in a electronic system, you can get only the power is on or power is off. So to represent that, we use this binary numbering systems. Numbering, like having only zeros and one, we call as binary numbers. So these numbers are based by twos, 2 to the power values, instead of 10, as we discussed in the decimal numbering system. So here you can see this is the way, this is an example of how the binary numbers are getting represented. So if you take one particular section, it should include numbers between 0 to 1. So that means it can include only two values, 0 or 1, either 0 or 1 value. Actually, we can convert decimal numbers into binary numbers. So I'm not going to discuss that in this video. I'll do a separate video on how we can convert these numbering systems. Otherwise, this video will get more lengthier. Our next numbering system is octal numbers. We in Sinhalese we call it as Ashtama Sankhya. In this case, we represent digits in the basis of 8. So here, if you take an example, 124. So one particular segment should have 0 to 7 numbers. 0 to 7 you can have to represent this particular section. So this here I have included the calculation how you can convert octal number into a decimal number. So you can see this is a superscript that was added here to represent what type of a number is this. So if you see a 18 here, then this number, this will be a octal numbering system. So if it is 10, it will be a decimal 1, but for decimals, we don't actually include this 10 here, since it's the default number system that we are using. So the same way that we have done for the decimal number system, you can calculate like this. So the first segment will be 8 to the power of 0, and the next will be 8 to the power of 1, 8 to the power of 2. Likewise, it will increase. And the way we have done for the decimals, you can do the calculation. So for the first portion, we have number 4. So you get 1 from the 8 to the power of 0, and then you multiply by 4. And the next one is you have 8 to the power of 1, which is 8. And there are number 2 is available, so you need to multiply. Then you get 16. The last segment in this particular example is number 1. So the third portion, it will represent as 8 to the power of 2, which is 64. Then 64 is into multiplied by 1, then it's 64. So 124 octal number is equal to 84 decimal number. So this is how it gets converted to octal into decimal. So this is just a high level conversion I have included. But in my other video, I'm planning to include a in detail conversion about how these things happen. So for today's final numbering system is the hexadecimal. Singalang api ෂඩ් දශමය සංඛ්‍යා සඳහන් කරනවා. So this in this hexadecimal, it will represent by the basis of 16. the numbers are having 16 in each positions in a numerical representation. This includes numbers from 0 to 9 and A to F. So this is how it looks like in the table given here. So the numbers will come as 0 to 9. And since you can't represent a single number with two digits, it will be converted into English character in capital letters. So up to F, we can represent a number. So here I have included an example how the hexadecimal numbers looks like. So this here you can see it's 8F2E. It's a hexadecimal value, and we can include the base as 16 to mention that this is a hexadecimal number. So to convert this, this will look like this. If it is a first number is 8, so we can, if you look into this table, it's 8 is, we can directly put as 8. If it is F, then we have to, when we do conversions actually, we have to include 15. And for 2, we can directly put 2. For E, E represents by 14. Likewise, we can convert this hexadecimal into the numerical value. After that, to convert it to decimal, the similar way we have done for the octal and the other decimal conversions. So we can segregate the portions into the power of 16s. 16 to 0 is first portion, 16 to 1 is second one, 16 into 2 is third. Likewise, the power increases. So the similar way that we have done previously, we can convert this hexadecimal into the decimal values. So this is a high-level overview, high-level introduction to the numbering system in computer science. So I hope you have got some idea. So if you have any questions, please include in the comments. Thank you very much.